Hey everyone, I wanted to go over a little bit in more detail for this section 9.2 notes when we were talking about linear regression. In section 9.1, we talked about this idea of sample correlation coefficient and this R that we're finding when we use StatCrunch, and how we can then also use the p-value to determine whether or not we actually have a strong enough relationship. If we do, then the next thing that we might want to do with that is try to predict using some sort of equation. And since we're talking about linear regression, it will be a line. And this line that we have is going to be called a line of best fit, possibly a prediction line, or a least squared regression line, which a lot of times you'll see abbreviated LSRL, or maybe just regression line. So whatever we name it or whatever we call it, we always use the same notation. We're going to use a y hat. So like our p hat, this is not just any y or any equation. This is a specific equation that will be this least squared regression line or the line of best fit. And it's going to normally, especially with StatCrunch, start off with the y-intercept, and then we'll have our slope and our variable. This is slightly different from what we're used to seeing when we see y equals mx plus b. So do be careful, especially if you're using your TI-84 calculator instead of StatCrunch. Then make sure you choose the correct one and know what it means when it says A versus B. So as you can see here, the B times X, that's actually our slope times the variable. So B is not the same thing in these two different equations. Now, unfortunately, we can always find the regression line, but we can't always use it. So there will be times when our correlation coefficient is not strong enough. Our relationship is not strong enough for us to be able to try and predict using the relationship. And so we'll have an alternative. And if we can't use the prediction line, then we just treat y as its own variable like we were doing back in chapter 2, and we'll just use the mean as our best prediction. We'll get to that in a minute though. So let's take a look at this example that we have. So we looked at this data, this gross domestic product versus CO2 emissions, when we were looking at section 9.1. And I did fix, so you might notice that this is slightly different from the graph on your notes. If you remember, the graph was missing those last two values. And so I did go in and put a correct graph so that we can see it. Those 2 points are added, and then this line is slightly different, has a slightly different slope than the one that you would have seen or would have had on your paper if you printed out the notes for class. I also, and I made sure and put this in a pink or kind of raspberry color type because I changed it. The p-value that I used in this sentence was based on missing, again, those two data pairs. So our p-value was actually 0.001, and we can do that again, find that number again. But we're wanting to find the equation, the regression equation. So that's our first goal, is to find that regression equation. And then we want to use it if we can. And since our p-value is so small, it really won't matter what our significance level is. We'll be able to use it. But we'll want to be able to make a prediction for a country with a GDP of $2.6 trillion, what would their CO2 emissions be? All right, so let's switch over to StatCrunch. I'm going to pull this over just a bit. So remember from section 9.1 and from our notes that we did in class, to get the correlation coefficient and the p-value to determine whether or not that relationship is strong enough, we went to stat and then regression. So linear regression, that's what we're wanting to look at. And again, linear, so simple linear regression. The only things we need to do are put in our x variable and our y variable. We are going to leave this as a hypothesis test. We don't really care about the hypothesis test about the intercept being 0 or not. Whoops. We only really are worried about whether or not the slope is 0. And so, sorry about that. Forgot that my pencil will sometimes write things. So we're not concerned about that first hypothesis test, but the slope, testing for the slope being 0 or not is the equivalent to testing whether or not the population correlation coefficient is 0 or not. Because if we have a positive relationship, then our slope of our line is going to be a positive slope. If we have a relationship that indicates it's negative, so the response variable is decreasing as that explanatory variable increases, then we're going to have a negative slope. So a negative correlation, negative slope. So we don't have to worry about changing anything. We can just click compute. We're going to get several different values here. We actually care about a few more than we did earlier. So before, we were talking about just looking at this R correlation coefficient, the third from the bottom of the list of values there. And then we also now can use this fourth line from the top where it says CO2 emissions. So as far as StatCrunch, we've got CO2, I'm going to just stop there, equals 56.0. I'm going to round to one decimal place for this one, plus 199.5 GDP. And so that's actually telling us it's even better than having the y hat and the x, that our CO2 emissions are going to be 56.0, what was it, millions of metric tons, I think, plus an increase of 199.5 million metric tons for each increase in gross domestic product. So in your homework, you'll probably be asked to fill in the equation, and I don't know if it just gives you boxes for the two coefficients, the intercept and the slope, or if it actually has you write out, because sometimes that might be a minus in front of the slope. But that's more likely than not how Pearson will ask you to answer the question. But that is what we want. That gives us our regression equation. And so what we're wanting to do, since our p-value is small, and if you remember, if we look over here, that p-value, you can check one of two. You can either look at the p-value for the slope. And again, we don't care about the p-value for the intercept. We only care about the p-value for the slope. Or you can look at the p-value for the model. That's just saying how well does the equation fit. So either one of those two will always be the same p-value. So you're going to look at that, and that's where we got our p-value of 0.001. So we can use this equation. And in order to do that, then what we would want to do is we're trying to find the CO2 emissions for a country with a GDP of $2.6 trillion. Well, that's going to be y hat equals 56.0 plus 199.5, and then this is our x value, 2.6. Now you can either put that in the calculator, or StatCrunch comes in to save the day again. We can actually, if we know what we need to predict, we can put that in. See where it says prediction of y there at the bottom. I can put in 2.6 and then click compute, and we get an extra table here at the bottom, and it's going to give me an x value and a predicted y value. I don't really care about any of those other numbers, right? So only that first number to indicate which x value I plugged in, and then that's 574.8 would be our value. So, and that was, I think, million metric tons. I may be wrong about those units, but I'm pretty sure that that's right. Now, what this equation, one other thing that this equation is telling us, and that's how would we interpret the slope. So the slope here would be that for, well, I guess actually I like using it with a per unit. So CO2 emissions increase by 199.5 million metric tons per increase of $1 trillion for their or for GDP. So for each $1 trillion increase in GDP, we will see an increase of almost 200 million metric tons of CO2 emissions. All right, so in this case, we were able to use the equation. If we're not able to use the equation, this prediction equation, or this line of best fit, then we're going to need to use the mean of the y values, which we use y bar. The only reason this is exactly the same as x bar that we've been seeing for almost the entire semester. That was the sample mean, but that was the sample mean when we only had one variable. Now we have two variables, so we're going to have two different sample means. So y bar is just, we have x's and we have y's, so we have a mean of the x's and we have a mean of the y's. So nothing extra special here, just we're looking at the other variable. And in this case, like I said, we get to use this equation for this example. But if we didn't, you can always find the summary stats for that column and make sure you pick the y, not the x. And if you want to, you can select it to where we only have the mean, so we don't have to dig through all the different values. And that would be it. So if we needed to, we could use the mean of the y values, 512, almost 513. Since I was rounding everything to one decimal place, that would round up. So 513 million metric tons of emissions for any x value. All right, I'll do another video where we look at an example like that, but for now, that takes care of the basics of linear regression.